First of all, I want to say what we did last week was just triangle trig, right triangle trig. So the biggest your angles could be is 90 degrees, right? Now we're talking about basically trig on the circle. And so our angles, well, they can be anything really. All the way around the circle is 360, right? Well, but you can keep going around the circle and around and around and around. You could have an angle of 2 million, which would be quite a few times around the circle, but that's possible. First of all, I want to talk about some of the terminology. I'm not going to go over it all right now, but this part right here. If you're talking about an angle in geometry, it's defined as simply two rays with a common vertex. That's what an angle is. When we draw angles here, we're going to care about which way you rotate it. And so, like here, if I want to say I started here and rotated in that direction, I draw an angle like that. So when you hear initial side, terminal side, that's all it means, is where you started and where you ended your rotation. Because here, the direction will matter. Okay, so those won't be the same angle because you rotated different directions. Sorry, it's so messy. And so, here, I'm not going to give you time to write this down, but you're going to do this according to this. It says an angle in standard position has an initial side facing due east. So down here on your paper, you put these directions here on your paper, and either draw the axes, or at the very least, draw the positive x-axis. So if you're trying to draw an angle in trig, your initial ray points due east, and then as it says, you rotate counterclockwise if it's a positive angle. So I want to draw 45 degrees, so rotate in a positive direction. In other words, you'll draw the terminal ray right down the middle of the first quadrant. And then draw an arrow like that, and you're rotating that direction. Because once again, a positive angle rotates counterclockwise around the circle. Yes? Okay. Let's draw the next angle. Once again, we start, we put our initial ray facing due east, and then I'm going to rotate in this direction. Now, that is more than 360, so it's going to go all the way around the circle and then some. How much more than a whole circle is it? If you do 405 minus 360, you get exactly 45. So this one actually ends up facing the exact same direction. So you do it like this. You go all the way around and you kind of spiral around. That was almost too close, but just do something like that, okay? In fact, I think I'm going to redraw mine. Doesn't matter really where you put it on here. You can go all the way around, and then more than 360, and there you go. And that's 405 degrees. Make sure you put degree marks. And then if you want to rotate backwards, then you're just going clockwise instead. So negative 315. Now let me pause for a second. We'll finish that picture in a second. What I want you to draw is a new set of axes below this. And make this a good sized picture because we're going to put a lot more on this. For now, we're just going to say due east is 0 degrees, due north therefore is 90 degrees. You should just memorize these. 180 is due west. How much is due south? And all the way around is 360. You're just adding 90 every time. 90 plus 90 is 180, plus 90 is 270, and then plus 90 gets you all the way around for 360. So those are called your quadrantal angles, which, by the way, one more thing, your quadrants go like this. Quadrant 1 is here, right? Quadrant 2 is here. They're numbered in that order because that's how you rotate around the circle in trig. You see it? Probably always seemed kind of weird that they were numbered like that, but that's why. 0 degrees is here, and you go that way. Now, if let's go backwards. I'm not going to draw it on here, but if I go backwards 90 degrees, I'm facing due south, aren't I? And negative 180 actually faces due west, but you're rotating backwards. So how much do you have to rotate to face due north? Negative what? Negative 270, right? So let me get back to the example we're trying to do. Negative 315 is more than negative 270, so it's going to be first quadrant. See that? And actually, it's going to be another angle that points to that same exact direction. I chose those angles especially so they work out that way. I'm sorry? No, I mean, I don't care, like, it's hard to draw all these on the same picture. Like, how far out you draw this arrow is totally irrelevant. If I was drawing it on its own little picture, if I was trying to draw just negative 315 by itself, you can put it there and rotate it, whatever. It doesn't matter where you actually draw the rotation. What matters is it starts here and goes goes clockwise that much around. And it's just, the size of these arrows and loops was totally irrelevant. It's where they stop and where they start the rotation, or where they start and stop. By the way, these three angles are special, I said, because they all end up facing the same way. There's a term for that. It's called coterminal. So write that down. And go and write the definition for coterminal angles. And we already have the picture, so obviously don't redraw that. And one important thing about coterminal angles, we're not saying they're the same. I mean, is it the same thing to rotate 45 degrees as it is to rotate 405 degrees? No, I mean, the end result may be the same. You may be facing the same way when you're done, but they're not the same amount of rotation. I mean, to really, I guess, emphasize the point, if I was to rotate 360 degrees all the way around, I'm facing due east, right? If I was to rotate around the circle 25 times and face due east, that's the same. I mean, it's coterminal. But you're going to be dizzy rotating 25 times, right? It's not the same amount of rotation. So coterminal angles are not the same. They end up facing the same way, but they're different amounts of rotation. All right, write this down. And just write the part where it says identify all angles that are coterminal with 80 degrees. Just write that one sentence down. We're going to do everything it says, but I'm not going to give you time to write all the directions. I want to draw a few of the angles. We'll list a few of the angles. We'll have to do more than that. So first of all, 80 degrees is the first quadrant, right? It's less than 90. So go ahead and draw that. And let me, by the way, just repeat that if you drew it like this without an arrow, you don't get credit because you have to show which direction you're rotating. Make sure you put the little arrow in it, in other words. All right, let's go all the way around. And then 80. How many degrees is that? Add 360. 440, actually. 80 plus 360 is 440, so that's another coterminal angle. We're going to draw them and list them. And actually, if I go another 360, I'm not going to draw this next one. If I do another 360, what do you get? 800. Another 360. And you can just keep going forever. And just to emphasize, you might write this down, we're adding 360 every time to get another coterminal angle. Now let's go backwards. Numerically, you just subtract 360. Well, 360 minus 80 is 280. Of course, when I draw it and when I label it here, it's negative 280. So make sure you're putting degree marks in all these. We're about to learn about radians, and we're not doing radians right now, so you have to make sure you put degrees. One more, if you do minus 360, what do you get? 6 what? Yeah. And once again, this list goes on forever. It's actually impossible to actually list all the angles that are coterminal with 80 degrees, because it's an infinite list. So in a case like this, what you're actually expected to do is write an expression So here, I'm going to read it to you after we're done writing it. That's the Greek letter theta to represent our angle. Set of all angles such that, the vertical bar says, that the angle is 80 degrees. And you can really pick any angle out of your list, but I'm going to pick the one they gave us, plus 360K. We usually use either like K or N when we write stuff like this. The letter itself doesn't matter. You need to note this. K is an integer. So that's really the proper way to answer this question. If you want a list of all the angles that are coterminal, that would generate the list. And we don't need it though. You're right. Because when I say K is an integer, this means it's a number with no fractional part, no decimal part. So K could be 1. Actually, K could be 0, first of all. When K is 0, you just get the 80. When K is 1, this would produce that. When K is 2, produces that. K is 3, produces that. It could be negative, though. Negative 1 is an integer. When K is negative 1, you get this. And when K is negative 2, you get this number, and so forth. So that formula, basically, will generate that whole list. By the way, just for the record, if you didn't put this right here, you're basically saying K could be any number, like any decimal. Then this is kind of pointless because you could actually generate whatever number you want with it, not just the ones you want. So you need to write that down as well, the part where that K is an integer. Okay? The other direction said, it said to draw, and we drew those. It said find one positive, one negative. The 440 is one positive, the negative 280 is one negative. We listed a lot more than that, didn't we? I'm just saying, when you actually do the homework, make sure you follow the directions. I did more than the directions called for. All right, write this down. The DMS stands for degrees, minutes, seconds. And the point is, it's kind of like doing like feet and inches. Or if you had so many hours, you can say, oh, it's 3.19 hours. But you probably want to express that as so many, 3 hours and so many minutes, and maybe so many seconds, right? So we're just talking about, it's a different way of writing degrees. Just don't write all this down. Just say convert or write this in DMS form. So just write the actual directions, okay? Use the word convert or write. Before we do this, I should tell you the conversions. So here, write this down off to the side. 1 degree of rotation is equivalent to 60 minutes. So it's just like time. 1 hour is equal to 60 minutes of time. 1 degree of rotation is equal to 60 minutes of rotation. So a minute of rotation is a 60th of a degree. And then 1 second of rotation, well, I'm saying it backwards, I'm sorry. 1 minute equals 60 seconds. So 1 second is a 60th of a minute. And just like when we're talking about time, but now once again we're talking about rotation. So I think about it, 1 degree is not much rotation. These are much smaller, right? One more thing. How many seconds in a degree? Yeah, 60 times 60 is 3,600. Just like there's 3,600 seconds in an hour. So write that down as well. Stop that. All right. There we go. Okay. What I want you on your calculator is we're trying to write this. That's a decimal number of degrees. So many degrees, minutes, and seconds. Just go ahead and write. Yeah, go get a calculator if you didn't already do so. Write your answer. It's 329 degrees. So just put the whole number down. We're going to take the fractional number of degrees now on your calculator. Hold on. All right, good. And just type in times 60. 0.125 times 60. I'm going to write this out so it's very clear. That was 0.125 degrees times 60 minutes per degree gives us 7.5 minutes. Okay? We're going to take the whole number part of that, put that in our answer. So that's how you write 7 minutes. Which is a single little mark. And now we're going to take the fractional part of that. Well, this is obvious, but we're going to write it down. So half a minute times 60 seconds per minute. Of course, half a minute is 30 seconds, right? Or half is 60 is 30. But we write that like this, with two little marks. And just to kind of give you an appreciation of how these relate, it's that many degrees in 7 minutes, but that's 7 out of 60, right? So 7 out of 60 is kind of a small part of a degree, which is why the decimal form was kind of small. So that's another way to express angles, yes. But we're not rounding. I mean, sure, if I asked you to round 7.5, it rounds up to 8, but that wasn't the point. You want to just put the 7 there, of 7 minutes, and the half minute is equivalent to 30 seconds of rotation. Okay? All right, now we're going to go backwards. So just write the directions below. It says, write this in decimal degree form. Just write that part. It's actually easier. All you're going to do is type in the calculator the whole number of degrees, and the 12 minutes is 12 out of 60. There's 60 minutes in a degree. And then that's 7 seconds out of how many seconds in a minute? I'm sorry, in a degree? 3,600. Just like the 3,600 seconds in an hour. There's 3,700 seconds. 3,600 seconds in a degree. And just type it in, you'll get a decimal number of degrees. So 35.202. It says round near 1,000, and that's degrees. All right, moving on. Now, before